Hello, my dear learner. Today we will see packing efficiency in body-centered unit cell. Okay, so let us see packing efficiency. We can say that packing efficiency is also called as percentage efficiency of unit cell. Okay, so let us see percentage efficiency or packing efficiency in body centered unit cell. In which unit cell? BCC means body centered cell. Okay, so let us see. So for a detailed understanding we have to draw a BCC unit cell. So how? See on the board how we are going to draw body centered cell. So let us see, this is, or suppose this is body centered unit cell. Body centered unit cell, we know that in case of body centered unit cell, particles are present on each corner, as well as in addition to the corner particle, one separate molecule is present at the center of the body. Okay, so these are corner particle and one particle is present at the center of the body. So this is nothing but BCC. Now to understand how to calculate the efficiency or percentage efficiency or packing efficiency, we have to join this sphere or this corner of the unit cell. Now again you have to join this corner also. Now say or assume that this point is A, this one is B, this one is C, and this is D. Okay. Now first of all let us understand this diagram. So in this BCC diagram or unit cell, we know that the edge length of the unit cell, let the edge of unit cell is A and radius of sphere is R. Okay, so if edge length, any edge length of this unit cell is considered as A and radius of this sphere is R, but you have to understand that this each and every sphere in this unit cell is not far away from this. So for understanding, we have joined this pair by lines, but actually this all sphere are touch to one another, because this is all about solid, and we know that in case of solid, sphere or particles or molecules are directly touch with one another. So if we consider this triangle first of all, if we consider this triangle, this will be 90-degree angle. Why? Because this line or this plane is horizontal, so it will be 90-degree here from this line, and this line angle will be here 90-degree, because this is three-dimensional arrangement. Particle is divided into how many axes? 3 axes. That's why this angle will be here, this angle will be 90 degrees. So we can consider here Pythagoras theorem. Now in this triangle, this angle is of 90 degree here also, because this is horizontal line and this is perpendicular. So like this, so it will be here 90-degree angle between horizontal line and this vertical line. Okay, so here also there is a 90-degree angle. That's why we can consider here also Pythagoras theorem. Okay, look at this triangle BCD. In this triangle, suppose this particle at this corner create here a 90-degree angle here. So if this is 90-degree angle in triangle BCD, angle BABDC is how much? 90-degree angle. Now, if this is 90-degree angle, and we know that this is edge length, this one is also edge length, edge length, edge length. Okay. Now, this is also edge length of the unit cell. Now, if this is 90-degree angle, then we know that according to Pythagoras theorem, we know that BC square is equal to CD square plus BD square. Okay. So this is applicable only for this triangle BCD. Why? Because this is 90-degree angle. Now we know that this CD and this BD both are edge length. So we can put here edge length A plus edge length A square. Okay. Now BC square will be, BC square is equal to how much? 2A square. Okay. Now look in triangle. In triangle A C B. In triangle A C and B. Okay. In triangle ACB, we know that this AC is edge length. Okay. Now this is a diagonal. Okay. Triangle or angle ACB is 90-degree angle. Okay. Now in this triangle, again use Pythagoras theorem. What will happen? This is hypotenuse. Okay. B or AB square is equal to BC square plus AC square. Now we know that this BC we have already find here. So AB square is equal to BC square plus AC square. Isn't it? Got it? Okay. Now we know that BC is nothing but 2A square. So AB square will be 2A square, and again this AC is edge length, so we have to put here A square. Got it? Now AB square is equal to 3A square. Okay. Now what will happen? If we cancel this square, then we have to take under root here. So AB equal to under root 3 into A. Now this is AB, and we know that AB is nothing but, suppose this is diagonal AB, so A and B, we know that these particles are exactly touching to each other. Now this corner is at the center of the sphere, so we will draw like this second sphere, and this one will be third sphere. Okay. So how many sphere are there? A and B up to this point, 3 sphere are there. Now we know that from this point to this, center to this, it will be radius of this sphere. Now we know that from this point to this center, there will be another radius. Again from this point to this center, there will be another one radius. And this is also from this to this, that is radius. So AB from this we know that, but we know that what it is, I will write here. AB is equal to 4. We know that AB is equal to 4R, isn't it? R. So it will be 4R. Now put in this equation. 4R is equal to under root 3 into A. Got it? If you have to calculate this R, then this R will be under root 3 upon 4 into A. Isn't it? Now, if you have to calculate edge length, then you have to take this on this side A will be 4 by under root 3 into 4 by under root 3 into R. A is equal to 4 by under root 3 into R. From this equation, we can calculate volume of unit cell, because for calculation of packing efficiency we must know the volume of unit cell. So how we can find volume? We know that what is the volume of cube, that is edge length cube. Now volume of unit cell A equal to A cube. A cube will be 4 by root 3 into R whole. So what is the cube of 4? It is 64. What is the cube of root 3? 3 into root 3, and this one be R cube. Okay. Now this is the equation or total volume of unit cell. Okay. Now we have to find volume occupied by how many spare are there in BCC unit cell. We know that in body centered unit cell there are 2 spare. Okay. Now we have to calculate or find out how much volume of this unit cell is occupied by that 2 spares. Now let us see. We know that what is the formula for finding volume of spare. So volume of spare is equal to 4 by 3 pi R cube, isn't it? So we know that there are 2 spare in a BCC unit cell. So we have to simply multiply this volume of spare by 2. So let us see what will be the volume occupied by 2 spare. 4 by 3 pi R cube. Okay. Now simply multiply this. 2 4s are 8 by 3 pi R cube. So this is nothing but total volume occupied by 2 spare in this BCC. Now simply we know the formula of the packing efficiency. What is the formula to calculate packing efficiency? What is the formula to calculate packing efficiency? We know that percentage efficiency is equal to volume occupied by spare upon total volume of unit cell. Volume occupied upon total volume multiply by 100. Okay. So this is the formula to calculate packing efficiency. Okay. Now put these values which we have already calculated. We know that this is total volume of unit cell. This is total volume of unit cell, and this is volume occupied by 2 spare. Now put the values of this into this equation. So volume occupied by 2 spare is 8 by 3 pi R cube, and 2 spare is 8 by 3 pi R cube, and total volume of unit cell is 64 by 3 into root 3 into R cube. Okay, multiply by 100. Now you got this, multiply by 100. Okay, now 8 is 64. This 3 and this 3 will be cancel. Again this root 3 and this root 3 will be cancelled. What is remain here? Here root 3, 8. This root 3 are on the denominator. Get pi into root 3 upon this 8 into 100. Got it? Now we know that value of pi 3.14 into what is the value of root 3? 1.73. 2. Again divide by 8 into 100. Now if you multiply this and divide by 8 and multiply by 100, the value will approximately equal to 67.9 something. So we will take it simply 68%. So what is the percentage of the BCC unit cell is occupied by two particles? 68%. Okay, got it? Now we know that we have already find this percentage efficiency of the BCC. Now if I ask you how much amount of empty space will be there in this unit cell, so just you have to, that is void. What does it mean? What is meant by empty space? Empty space means the void present in the unit cell. Void it is equal to 100% minus 68%, isn't it? So you will get that how much void will be there in this unit cell. So how much void will be there? Please comment in the comment box. What is the volume or void present in the, or empty space present in the BCC unit cell? Okay, thank you.